Hi, in this video I'm looking at this problem here, evaluating the integral between 0 and pi on 3 of 6 sine squared 4x dx. Now the trick in this integration is the sine squared. So to tackle this sine squared, I'm going to use a trigonometric identity. And the trigonometric identity I'm going to use is one of our double angle identities. The one is that cos of 2x is 1 minus 2 sine squared of x. And this identity will change my sine squared into a cos, because I'm going to replace the sine squared with whatever the value of sine squared is with this rearrange. So to rearrange this, I'm going to get rid of this 1 from this side by subtracting 1 from both sides. So I'm going to have cos of 2x minus 1 equals negative 2 sine squared of x. And then I'm going to divide both sides by this negative 2. So that's going to have negative a half outside of cos of 2x minus 1, which is just going to be sine squared of x. Bring the negative in just to tidy this up, and we've got a half outside of 1 take cos of 2x, because the negative 1 becomes positive 1 and the positive cos becomes negative cos, giving us sine of 2x. So now I can replace my sine 2x in my integration with my half of 1 minus cos 2x. I've just got to be careful because this is for sine x, but I've got sine 4x. So when I go to do my cos 2x, I've got to double whatever's inside my brackets over here. So let's go do this. So integration becomes the integral between 0 and pi on 3 of 6, and I'm going to replace it with this half outside of 1 minus cos of 2 times whatever is inside the brackets here, 4x dx. So tidying up this integration a little bit, we've got the integral between 0 and pi on 3, and 6 times a half is 3, and I'm going to times that by 1 minus cos, and 2 times 4x is 8x, and we're still with respect to x. Now I'm just going to move this 3 out the front so I can do this integration without having to worry about it being there at all. So you're going to have integral from 0 to pi on 3 of 1 minus cos 8x dx, all multiplied by 3. So now performing this integration, I've got 3 outside of, and we're going to have integration of 1 is just going to become x, and integration of cos is sine, so we're going to have minus sine 8x, but of course we've got to divide by that 8, and that's going to be between 0 and pi on 3. So now we've got, substituting our values in, I'm going to have 3 times pi on 3, which is going to go in place of the x, so I guess I've got pi on 3 minus sine 8 pi on 3 on 8, and that is going to all be minus x with 0, so you have 0 minus sine of 8 times 0, on 8. And closing off our brackets. So I've got 3 times by these two terms being subtracted. So we've got 3 times by pi on 3 is still just pi on 3. We can't change it. So we're still going to have pi on 3 minus, well, we've got sine of 8 pi on 3, which is going to be the same of, well, if we think about this, this is 6 pi on 3 would be 2 pi, which is a full revolution. So we've got 2 pi left over. So it's going to be 2 pi on 3 left over. And we've got 0 minus sine times, well, 8 times 0 is 0. Sine of 0 is 0. So all of this cancels out. So I'm left with 3 times pi on 3 minus sine 2 pi on 3 on 8. So now we've just got to evaluate what sine of 2 pi on 3 is. So we've got 3 multiplied by pi on 3 minus sine of 2 pi on 3. Well, if we think about our unit circle, 2 pi on 3 is over here. So that's 2 pi on 3. So if we take the angle back to the x-axis, that's pi on 3 in our second quadrant. So if we have a look at our triangle of 1, 2, root 3, pi on 6, pi on 3, sine is opposite over hypotenuse, and we've got pi on 3. So our opposite and our hypotenuse are root 3 on 2. So the sine of 2 pi on 3 becomes root 3 on 2, but we've still got our 1/8 sitting there, so it's still multiplied by 1/8. So we can start tidying all of this up now. So if I open up this brackets, I've got 3 times pi on 3. Well, the 3's cancel out, so I've just got pi. Minus off, we're going to have 3 lots of root 3 on 2 times 8 is 16. So there we have it. Our integral between 0 and pi on 3 of 6 sine squared 4x, which we got rid of the sine squared by using our double angle identity cos 2x equals 1 minus sine squared x. Simplified it, worked it out, and we got 8 minus 3 pi, pi minus 3 root 3 on 16.